So blood entering Bowman's capsule gives up a large amount of fluid to the beginning of the nephron. So here's Bowman's capsule. Well, it would surround this ball of capillaries. That's the glomerulus. Bowman's capsule is this part, and the glomerulus is this bunch of capillaries. If we blew that up, if we looked at it at higher magnification, what we'd see is these capillaries that are leaky. They have gaps between the cells. So here are a bunch of capillary endothelial cells. They have a basement membrane that I'm not showing you. And wrapped around them would be these finger-like projections coming from cells that provide some structural support and help to filter. So these are called podocytes, foot processes, or cells with what look like feet. And if you think of your interlaced fingers over a tube, that's what they would be like. And the waste material is coming out of the capillaries. So it's coming out of the capillaries under pressure, and from the capillaries is entering Bowman's capsule. Black lines here are representing an epithelial tissue layer, and the fluid is moving across through gaps. And what gets in, if we zoom in here, is going to be, of course, water, but then many small molecules. Sodium, of course, chloride, calcium, glucose, amino acids, wastes such as ammonia and ammonium, urea, which is your major nitrogenous waste in a mammal and a human. So, and many other things. Drugs that you take, the small molecules that are many of those drugs, they'll wind up in the filtrate here. The material that's being produced here is called filtrate. It's not yet urine. It's going to develop into urine. So that filtrate gets into the first part of the nephron. So let's move on to that. So I'll redraw Bowman's capsule. And now I've added to it the proximal convoluted tubule. In the proximal convoluted tubule, a lot of these molecules that were picked up wind up being moved out by, for example, secondary active transport. So sodium is being moved out along with glucose, and amino acids also being moved out in this way. Chloride follows passively, simply because of the charge gradient. Calcium is being moved out by calcium pumps. So valuable molecules and ions are being recovered, and what gets left behind is the waste. In addition to the valuable molecules, there are aquaporins here. Remember, aquaporins are water channels. As we move solutes out, water follows passively. So as these ions are being recovered, water is also being recovered, and in fact a large amount of the volume of material that gets into Bowman's capsule is recovered in the proximal convoluted tubule. You might be wondering where that water goes, and if you remember, we had a blood vessel coming out of the glomerulus. That blood vessel is moving along here, and remember, capillaries are leaky, so the capillaries in this region, again a basement membrane, but of course all of these are small molecules, and so the chloride, the sodium, glucose, calcium, they all are diffusing because they're in locally higher concentration here. They're at higher concentration here than they are in the blood, so they move into the blood. And we've also got water here, and water will follow as well. So in the proximal convoluted tubule, we're recovering valuable molecules Water follows passively through aquaporins, and of course left behind, the things we haven't gotten are things like ammonium ion, which can't cross membranes easily. Ammonia can, but ammonium ion can't. Urea, and many other wastes. And of course, there are a few valuable molecules still left here. We can't get every last one. So that's the function of the first part of the kidney. And in fact, if we were looking at a fish or an amphibian, this is pretty much what a kidney does. There's Bowman's capsule that's producing the filtrate from the glomerulus, the ball of capillaries in there. The material gets in, valuable molecules are recovered, the others are left behind, and it eventually would be excreted. In a mammal, however, we add another piece that I'll talk about in a moment.